In this video, we will be discussing heat engines and the laws that govern them. The first law of thermodynamics states that a change in energy in the system is equal to the heat added to the system minus the work the system does on the surroundings. Basically, the first law is the same as the conservation of energy because it can also be written as this, which shows that the change in energy in the surroundings equals the change of energy in the system. The second law of thermodynamics states that in a closed system, the entropy can never decrease. For those of you that don't know, entropy is the amount of disorder in a system, which is what you can see is going on here. Basically, this restates that the second law means that the change in enthalpy is always greater than or equal to zero. As you can also see, entropy is equal to the change in heat over temperature. Heat engines are a device that converts heat into work by taking heat from a hot reservoir and then transferring some of that heat into energy and the rest into a cold reservoir. An ideal heat engine would transfer all heat into work, making the process reversible. In reality, though, not all energy is transferred to work. Some of it is lost to things like friction, which causes the entropy to increase. Because of this process is non-reversible. There are two different types of engines. The first one is the external combustion engine. In this, the fuel combustion heats another liquid, and that fluid does the work and releases the heat. This is what you typically see in a steam-powered plant. This engine can also be called the Rankine cycle. On this card, you can see that we drew a graph of temperature versus the entropy. This graph shows how the cycle works. So as you can see, from 1 to 2, the water is pumped to high pressure and ejected into a boiler. From 2 to 3, the water is heated to boiling point. From 3 to 4, the water is then completely converted to steam. From 4 to 5, the steam is further heated to be beyond the boiling point. From 5 to 6, the steam flows through a turbine which does the work. And from 6 back to 1, the low pressure steam is condensed back to liquid and then once again pumped through a boiler. The other type of engine is the internal combustion engine. In this, the fuel combusts in the engine, which does the work and releases the heat. This is typically what you see in a car engine. This cycle is called the Otto cycle. In this, air is compressed and expanded in order to move a piston that does the work. You can once again see a temperature versus entropy graph. In this, from 1 to 2, there's isentropic compression from volume VE to VC. From 2 to 3, there is constant volume heating due to the combustion of a fuel-air mixture. From 3 to 4, there is once again isentropic expansion from VC to VE. And from 4 to 1, there is constant volume cooling. This video was just a brief overview of heat engines and the laws that limit them.